first in the equation. Okay? And we need to remember how we find C, how we find A, and how we find B. Right.
This test is going to be really hard. So, are we going to be using the same form? Distance and midpoint?
Just hold on. Yes, we will be using distance and midpoint formulas in this lesson. All right? Okay, we are going to be tonight writing the equations of ellipses. We're going to have, yes, you can write this, because there are 3 things you have to write the equation of an ellipse.
Yeah.
Can I do what? Over where?
I can't read it.
Oh.
It says 2. That's it. That's all. Yeah,
Remember, for a circle, we needed the center and the radius. Well, an ellipse is sort of like a circle, right? We still need the center, but why can't we just have one radius? Because it's elongated. Very good. So we need to know how far to go in one direction and how far to go in the other direction. Okay? So we need to know the center, we need to know the value of A, and we need to know the value of B. Again, by raising your hand, can somebody tell me what the value of B represents? Dwight? Not the whole thing. It's half of the minor axis. Okay? It's half of the minor axis. And what does A represent? Half of the major axis. All right? In this picture,
will the center, like,
You draw that?
will it always be on the origin?
no. But we're starting easy. Okay?
Easy.
His question was, will the center always be on the origin? No. But we're starting simple right now. We're going to gradually get worse. I mean, more difficult would be a better word. All right. Specifically, okay, you've got to go with the information that you're given. You can't just go by what it looks like. All right. First off, major axis. Is it the Y or the X? The Y axis. How can you tell what the major axis is, Jacob? The longer way. Okay? The longer axis is the major axis. So right now, when I'm going to write my equation, what's going to come first? X or Y? All right, so I know that part already. The next part I need to know is what's the center of this thing?
3.
Well, here's my center. It's exactly 6 units away here and 6 units away there, right? So my center is 0, 0.
With the center always be just the coordinate that's on.
Mm-hmm. It's a coordinate. Right, it's an X and a Y. Now, somebody remind me what A represents? Okay, now what's convenient about these is that since A and B are on vertical and horizontal lines, all we have to do is count. How far is it from the center to the edge of the major axis?
6.
6 units, so A is equal to 6.
On the center to the
1, 2, 3, 4, 5, 6. That's A. Now, why can't I go straight to B?
Because it's not
Because we need C.
I don't know what these coordinates are. Okay? But I can use C to help me find it because I do know the foci. And how far is it from the center to the focus? 3 units. All right. Now hold on a second because I forgot to point this out. All right. I want you to see where this is derived from. This is a right triangle here, right? In the Pythagorean theorem, we can find one of the missing sides. But in this actual illustration, which letter represents the hypotenuse? A represents the hypotenuse. Okay? So if I have hypotenuse squared equals leg squared plus leg squared, how did I get from there to this?
Switch out your C squared and your C in your A squared and subtract.
Don't I just move this over here? I subtract b squared from both sides? Okay. So when you see this, that's where it stems from. If we know C and we know A, we can figure out what b squared is equal to. And for right now, all I'm doing is writing the equation. And in the equation, I'm supposed to put b squared. So I don't have to worry about taking the square root. I'm just going to find what b squared is. 3 is the distance from here to here.
It was given to you.
1, 2, 3. This was a part of the problem. We figured out that the center was here and the distance is 3 units.
That's C, like she told us that C is the focal.
Right.
It's the focal.
C is the distance from the center to the focus. All right. So this is 9 is equal to 36 minus b squared, which means if I bring my b squared over here to make it positive and subtract 9, what is b squared equal to? 27. And I have the information that I need because watch. I already said y comes first because of the direction of this thing. And I'm supposed to subtract the y coordinate of the center. So I'm subtracting nothing from this, and then I square it. And then I'm supposed to subtract the x coordinate of the center, which is 0, and I square it. And this is a squared. What was a squared? 36. And what goes under here? B squared, which I just found. B squared equals 27. And you have the equation of your ellipse. Right now we're focusing on simply writing the equation.
It's going to be one of those other week ones, or 2 or 3
One of
days.
those tests from Satan himself.
What are the 3 things you have to know to write the equation of an ellipse? You don't need C. The center, A, and B. You need to know the center, you need to know A, which is the distance, and you need to know B. In most of these cases, we're going to need C to find B. Unless the actual endpoints were given to us, then we wouldn't need C. No. Now, if we were, you would have to take the square root of 27 and do that. All right. Draw this picture. We're going to write the equation of this ellipse.
So the sum of the 0, 0 again?
The center, again, is 0, 0. And you got to make sure, okay? This time, my major axis is what?
X.
The x-axis. So in my equation, the x is going to come first.
Why would it be X?
Because the x-axis is the longer axis. Horizontally.
Oh, I got it.
Okay? This, your y-axis, is shorter. So it's the minor axis. All right? Can someone tell me the value of A?
Oh.
No.
9 squared.
9. The value of A is 9.
C is 6.
How do I get that?